Okay, so Sunny, let's proceed ahead with your technical snap for thermodynamics. Tell me, what do you understand by the term entropy?
Entropy, sir. Entropy is a measure of degree of randomness, basically. Hello.
Degree of randomness.
Yes, sir. Yes, sir.
What do you mean by that?
Degree of measure of random.
What do you mean by that?
So, like if we give energy to if we provide some heat energy to a solid body, so in solid, since molecules do not translate, but they will their internal energy will keep on increasing. So they increase in internal energy on certain energies which we can't measure. There will be some randomness. And
what is the significance of calculation of entropy change?
Significance of calculation of
entropy change.
So we can measure irreversibility.
Sorry, irreversibility.
Yes, sir. Unavailable energy, which.
But irreversibility is something which is related to entropy generation, not entropy change.
Okay. Entropy change.
How do you calculate entropy change of universe?
Sir, we since universe is an isolated system, so we calculate entropy change of universe, entropy change of system plus surroundings.
Okay, and Sunny, can you write the second law of thermodynamics?
Yes, sir. Second law for thermodynamics, yes, sir. It's dq by T plus delta S generation is equal to ds. dq by T plus delta S generation is equal to second law of thermodynamics, dq by T is less than equal to 0. Cyclic integral of dq by T is less than equal to 0.
No, that is inequality. I'm saying equation.
So you asked for second law of thermodynamics?
I'm saying second law of thermodynamics ka equation.
Second law of thermodynamics equation for dq by T plus delta S generation is equal to ds.
But then we need to clarify entropy generation term also from this.
Sir, entropy generation is basically
ds is equal to dq by T plus ds generation, right?
Yes, sir.
Now, can you tell me what is the difference between an isentropic process and reversible adiabatic process by seeing this equation?
Sir, in reversible adiabatic process, reversible adiabatic process basically is an isentropic process where change in entropy is 0. Here, delta S generation is 0. There is no irreversibility.
Okay.
And whereas adiabatic process, adiabatic, sir, you asked difference between reversible adiabatic and adiabatic.
Reversible adiabatic and isentropic.
Reversible adiabatic. Sir, isentropic process where entropy is constant, entropy doesn't change. And a reversible adiabatic process where delta S generation is equal to 0.
Okay. Tell me what is enthalpy?
Enthalpy, sir. Enthalpy means total heat content of body, which is given by U plus PV, which is given mathematically given by equation U plus PV, where U is an internal energy and PV is the flow work.
Okay. Sunny, can you tell me the two statements of second law?
Yes, sir. It's one is Kelvin-Planck and other is Clausius statement. Kelvin-Planck states that there cannot be a machine which can convert total heat energy into work. Whereas Clausius statement states it is not possible to design or manufacture a machine wherein heat transfer from a lower body temperature to a higher body temperature without an aid of external agent.
If I give you a glass of water,
yes, sir,
can you calculate the entropy in it and enthalpy of water in it?
Glass of water entropy. Yes, sir, we can calculate. entropy, glass of water. For solid or liquid is MC ln of T2 by T1. So where we have to take in this T1 we will take as ambient temperature, and
Okay.
T2 will take ambient temperature and T1 will take as reference temperature. We will assume that entropy at 0 degrees. If we'll take reference temperature 0 degrees Celsius, so we assume that entropy at 0 degrees Celsius is equal to 0. That's how we can proceed.
Okay, now Sunny, tell me something about the third law of thermodynamics.
So third law of thermodynamics states that absolute 0 Kelvin temperature, there cannot be temperature cannot be 0 Kelvin. Absolute temperature cannot be 0 Kelvin.
Okay. What is the significance of 0 Kelvin?
Significance of 0 Kelvin. So 0 Kelvin, basically temperature is a measure of motion of molecules. We can say that it's a function of velocity of molecules. So in 0 Kelvin, the energy will always be displaced by either solid or gas molecules. We cannot attain such a situation in which there will be no energy displaced by molecules. So temperature cannot be 0 Kelvin. Energy, individual molecule possess some kind of energy which basically gives an idea of about temperature.
And tell me different types of thermometers, Sunny. Which kind of thermometers do you have?
Thermometers, so we mercury-based thermometer we use in our houses for checking body temperature. That is all I know about thermometers. I haven't seen other thermometers.
Okay. Okay, then Sunny, let me give you feedback. सनी देखो आपने रिवाइज किया है, लेकिन थर्मोडायनेमिक्स ना बहुत इन डेप्थ वाला सब्जेक्ट है.
ओके सर.
उसमें ना कुछ कंफ्यूजन हो रहा है, थोड़ा कंफ्यूजन है उसमें. तो उसमें आपको 2-3 बार उसको रिवाइज करना पड़ेगा जो मैराथन है आपका.
ठीक है.
जैसे वहां पे ये सारे टर्म्स बहुत क्लियरली रखे हुए हैं.
ओके सर.
और आपको ये सारी की सारी टर्म्स को बार बार देखना पड़ेगा, ऑल दीज थिंग्स.
ठीक है सर.
अदरवाइज थोड़ा मिस्टेक हो जाएगा और उसकी वजह से गड़बड़ हो जाएगी. थर्मोडायनेमिक्स को 3-4 बार देख लो जो मैराथन है, उसके बाकी सब्जेक्ट्स हो जाएंगे आपके, नॉट अ प्रॉब्लम.
ठीक है सर.
राइट, दैट इज हाउ इट इज टू बी डन.
ठीक है सर. ठीक है सर.
बाकी द रेस्ट इज ओके. आई थिंक यू हैव गॉन थ्रू दिस, बट वेरी इंट्रिकेट पॉइंट्स पे यू आर गेटिंग कॉट.
ओके सर. सर एक दो एग्जांपल बता देना अभी आज के, जैसे मतलब अगर आप क्लैरिफाई कर दो
कि जहां पे प्रॉब्लम आ रहा था. जैसे आपसे मैंने पूछा कि सेकंड लॉ की इक्वेशन लिखो, इरिवर्सिबिलिटी एंट्रोपी जनरेशन होता है, एंट्रोपी चेंज ऑफ यूनिवर्स कैसे निकालते हैं, इनके आंसर सेटिस्फैक्टरी नहीं आ रहे थे ना आपकी तरफ से.
ओके.
ये मेन चीज है. राइट.
ठीक है. ये हॉट टॉपिक्स आ गए, एंट्रोपी. ठीक है सर. फाइन सर.
ओके.
थैंक यू.